Would you want to live to be 120 years old? Dr. Nir Barzilai and Dr. David Sinclair now discuss this topic with moderator Jamie Metzl.
Hello, everybody. I'm Jamie Metzl, founder and chair of OneShared.World and author of the book Hacking Darwin, Genetic Engineering and the Future of Humanity. And I could not be more excited to welcome you to this conversation about my favorite topic with two of my very favorite people in the world. Our topic today is living healthily to 120 and beyond. We all want to live long and healthy lives. We have so many examples from mythologic history of Methuselah living to 969 and so many others. But in the Bible, just a few passages after Methuselah, we have the author, you know who, saying, well, after now, 120 is the limit. But we have an example of a woman, Jean Calment in France, who we believe lived to be 122 with a lot of activity and a lot of health and eating 2 pounds of chocolate a week for the big part of her life. So when we think about aging, it's not about living forever. It's about unlocking human potential. I mentioned my very favorite people, and those are our guests today. Nir Barzilai, who's the Rennert Chair for Aging Research at Albert Einstein College of Medicine and author of the wonderful book, Age Later. And David Sinclair, the co-director of the Harvard Glenn Center for the Biology of Aging Research and author of an also wonderful book, Lifespan. So let's just dive in. Nir, I mentioned in the beginning, this difference between lifespan and health span. I mean, it's this everyone says they want to live a long life, but nobody wants to be a vegetable. So what's the difference between lifespan and health span, and how can we measure certainly health span?
Well, the difference, all the difference is that David's book is lifespan and my book is health span, but you cannot really actually distinguish between them, because what we have found as geroscientists is that we can target aging, and if we target aging, then we delay diseases and we live healthier. And so if we delay disease and live healthier, we'll also live longer. So in fact, we're talking about the same mechanism. And if there's any difference, it's just because for many people, longevity somehow is a curse. They think that they don't think that they live healthy as they live longer. And that's the thing that we kind of have to change. We can live healthier, and the side effect is living longer. What's bad with that?
Yeah, we should be blessed with that curse. David, there's a debate in the aging research community about whether aging is a lot of different independent things, or there are some overall systemic mechanisms of aging. What is aging in your view?
Well, like all good scientists, we do debate things. That's our job. But fortunately, over the last decade, we longevity researchers, we call ourselves, have come upon a list of about 8 major causes of aging that we all agree on. And so some of these are well known. These are shortening of the ends of chromosomes, the telomeres, the loss of stem cells, cellular senescence. These cells are like zombie cells that accumulate in the body. The loss of mitochondria, which are the power packs of the cell. And the list goes on. There's one called epigenetic alterations that may be a major part of that. But science is always dynamic, and we're discovering new things all the time. But what we're really, I think, looking for here, which would be super exciting, is are there 1 or 2 major causes that lead to these other bad things that happen to our body? And in that way, we could theoretically intervene, slow down the aging process, and stay much healthier for longer, as Nir mentioned, and therefore we live longer as a result.
Yeah, that's such an important point. So Nir, you have brought together one of the largest cohorts and studied one of the largest cohorts of centenarians to learn, well, what are the lessons, the biological and life lessons from these centenarians? Can you talk a little bit about that and about the genetic lessons that we learned from that study?
Sure. So the major question is, if you get to 100, do you get your disease when you're 60 like everyone? and all you do is live longer with disease? And the answer is not. Health span and lifespan in this population goes together. They live 20, 30 years healthier than a control group. And that's not what's most exciting. What's most exciting is that they have what we call a contraction of morbidity. They spend very little time at the end of their life sick. 30% of them just don't wake up in the morning. So we can achieve that. We are built in to achieve it. There are lots of genetic component to exceptional longevity, genetic component that slows aging. And one of the major one in our centenarian is the fact that all the growth hormone mechanisms are impaired. A lot of genes of growth are impaired because we need the growth hormone when we are young to build the body. But then with aging, our body starts to break down. We have to shift the energy from growth to protection. And we can find it in our centenarians among other genes.
Yeah, it's so important. And we'll come back to that about those kinds of hacks and how different interventions can shift that balance between growth and repair. But before we talk about the kind of hacks that seem a little more aggressive, David, let's talk about the hacks that are available to everybody, the blue zone stuff, lifestyle. Can you talk a little bit about, if you want to live long, what are the really practical things that you can do? And then connected to that, in our evolutionary history, all of our ancestors have gone through these starvation funnels where most everybody else died, but our ancestors made it. Can you talk a little bit about evolutionary history and how that contributes to calorie restriction as one mechanism?
Right. Well, if there's one thing that I would recommend or suggest to live longer, it would be eat less often. We live in a world of abundance now with 3 meals and snacks. This is what it's actually doing to us, besides make us obese, is it's turning off our natural defenses against disease and aging that we have. And these are controlled by longevity genes that Nir and I and many others in the field have discovered. So you want to put your body in a state of perceived adversity. Run a little, move, lift weights, eat less often, eat the right foods, and then your body responds and fights against deterioration. Unfortunately, the world that we have is we love comfort, and this is actually accelerating our aging. So we need to really just get off our behinds, don't eat so often, and get those longevity genes to work and protect us over the long run.
That's great. And then, Nir, you've been the world's champion on studying one particular intervention, Metformin, and you're targeting Metformin. Your TAME initiative is not just about seeing whether Metformin can work as a tool for addressing the comorbidities of aging, but establishing whether we can have the kind of systemic intervention that can pave a way for a whole field. Can you talk a little bit more about that?
So first of all, David mentions the hallmarks of aging, and he mentioned that when you target one, you actually affect some of the others. And that's what happened with Metformin. Actually, we published a paper showing that it attacks all the hallmarks of aging. Why is it? It's really simple. It happens in the drugs that David developed, the resveratrol kind of drugs, and rapamycin, which is another drug. When you take the cell or organ and body and make it from old to young, you're going to change all those hallmarks. And that's what happened when you have a true, what we call geroprotection. Metformin for us is a tool to get a new indication that is a prevention of age-related diseases, something that the FDA doesn't totally grasp. Nobody really grasped this concept yet. And that's why it's so important that we're here, to show that we can prevent a bunch of age-related disease by just targeting aging more specifically. And so Metformin is a drug that's safe, has been used for decades. It actually was used first to prevent flu and malaria when it was discovered that it has anti-diabetic properties. But people on Metformin have less diabetes, have less heart disease, have less Alzheimer, have less cancer, and they even have their mortality of people with diabetes on Metformin is less than people without diabetes. So this is an important tool to show that we can target aging, and then lots of drugs will be developed in combination, and we can really achieve what we're trying to, living healthy until 120.
Yeah, so important. And David, you are, in addition to being famous for your good looks and charm, you're also famous for, yeah, exactly, as you can see, for your information theory of aging. Can you talk a little bit about what that is and how that points us in the direction of, excuse me, of interventions that can help us live healthier longer?
So the idea really behind this is there something controlling the hallmarks of aging? Is there something that goes wrong over time that could potentially be reset? And over 25 years that I've been working in this field, working on little yeast cells that make bread and beer all the way up to humans, what the data is pointing to is that one of the major drivers of aging is the loss of what we call epigenetic information. And briefly, what that means is we have two types of information in our body. We have the genome, which is the DNA, and then we have the control systems, which are the epigenome. An analogy would be a compact disc where the music is the genome and the information in the DNA. It's very robust. And then the epigenome is the reader to read the right songs at the right time. And aging, I think of as scratches on the CD, so you cannot read the right songs at the right time. Or in the case of the cell, you cannot read the right genes at the right time. And that's what we call epigenetic decay. And that might be a root cause of aging that leads to many other problems that we've talked about. And drugs like Metformin slow down the accumulation of the scratches and perhaps even erase some of them, which is exciting. But the most exciting part about this theory, if it's correct, is that the music of our cells is still there. If we polish those scratches, we can get back the youthful music of our lives. And that's what we're trying to do now at the forefront of this field.
Amazing. And so can you talk a little bit about David, about the different interventions that could polish away those scratches? You mentioned Metformin. What else?
We and a few other labs work on a molecule that we naturally make a lot of when we're young. It's called NAD for short. For long, it's nicotinamide adenine dinucleotide. And it's the molecule that keeps us alive. Without NAD, we're dead in 30 seconds. It's required for mitochondria, the power packs, to work, among other many reactions. And metformin is playing a role in that. NAD is important also, not just for energy, but for regulating a set of longevity factors called the sirtuins that we've worked on for many years. And as we get older, we make less of this molecule, NAD, and we think that our defenses get less and less. And you can accelerate this decline in NAD by not exercising and eating too much. Ultimately, what we're trying to do is make drugs that will raise the levels of NAD back up to youthful levels and get the body to fight as though we'd been running marathons and eating perfectly. And those drugs are actually in multiple clinical trials across the US. There are many others, by the way. There's rapamycin, Nir mentioned, that mimics low protein diets, which seems to be very effective in animals and seemingly in people as well to rejuvenate. And there's a growing list of molecules that are either in labs or in human clinical trials that look really promising, so that metformin and rapamycin won't be the only ones on the market that we can access shortly.
So 20 years from now, Nir, when you are chronologically 20 years older and based on these kinds of interventions, biologically X years younger, and you're in your clinic and somebody comes in and you say, I've diagnosed the problem that you're facing, it's aging. And here's the treatment for aging. 20 years from now, what do you imagine that treatment looking like?
First of all, it will be telemedicine in 20 years. I'm not going to see the patient in my office. But let me take you back to a previous Vatican conference where Biden and the Pope were the keynote speaker. And Biden came, he was vice president then. And he came and he had the Moonshot Cancer Initiative. And I'll tell you, cancer is so much more complex than aging. Okay, it's really a problem because every cancer is different than the cells in your body. It's different than any other cancer. It's a huge problem. And aging is actually a quite simple thing to do. The challenges are not at all, except that if you prevent aging, you don't only prevent cancer, you prevent many other age-related diseases. So it's clearly the future. In fact, the Pope said, after Biden's talk, he said, I still hope that there's just a little pill that will cure cancer in everyone. And I think metformin is as close as it comes. It's already existing. So the only thing, unfortunately, the animal that lives almost the longest proportionally is turtle, okay? And the turtle, the problem is very slow. and really the rate is not as great as it should be, or we hope it would be. But I think that 20 years, there'll be all those drugs that have been repurposed and totally new mechanisms and new approach that it will extend lifespan very significantly. And I'm not sure that 120 needs to be really the limit, although this is kind of our maximal lifespan as a species. But, I think the future is open.
Yeah, and it's exciting because there are these types of interventions, and that's going to, it seems to me, intersect with our future of precision health and ultimately predictive health. And so the way I would imagine is that we have all of these different types of interventions, and we know a lot about the individual biology of each person, and then we're able to increasingly customize interventions. So David, we're here speaking for the Vatican. So this isn't ultimately a conversation about exciting science. Exciting science brings us to the table, but the conversation is ultimately about ethics and values. How can we make sure that our most sacred values and ethical systems, including our ancient ones, guide the applications of our most powerful technologies? And when we think about aging, there's kind of different ways that we can look at it. On one hand, if we're trying to increase average healthy lifespan globally, by far the best intervention that we can make is helping everybody around the world live lives that will allow the kind of benefits that we've had in wealthier countries over the past century, with water, sanitation, basic safety, healthcare, all of these kinds of things. So that's one absolutely necessary intervention. The other is population-wide. How can we enhance healthy lifespan? And if we're health span, and if we do that, the inventions, the love that even a subset of us are able to deliver, I think, in my view, will help everybody. And then there are kind of, when most people think about extending lifespan, they think about crazy Silicon Valley billionaires who are pushing these frontiers. So David, is there a way to weave all of these three things together? Because we want the investment, the venture investment, the people kind of taking some big risks, making big bets, and we want to do the public health stuff. How do we, from an ethical perspective, how do we weave those three different stories together?
Well, briefly, what we need to do is enhance what we're already doing as a field. In the last 10 years, we've gone from just a bunch of scientists at conferences and really very few people listening, and thanks in part to books that are being written by you guys. The public has woken up, not everybody, but a lot of people have realized that addressing aging is the biggest impact we can have on human health by far. If you smoke, your chances of lung cancer go up 5-fold, but aging from 20 to 70 increases it over 100-fold. So aging is the major cause of not just cancer, but most suffering on the planet. So if we can address that, it would be a huge economic benefit and also social benefit. And we'd have money left over to tackle these other big problems. So this is a really global and important initiative, but we need a grassroots effort. We need more investment in research. There's very little investment into aging biology compared to cancer and heart disease. And tackling one disease at a time has actually led to problems. We can keep the heart alive for a long time, but the brain still ages. And our approach is the opposite. We want to keep the whole body alive for longer. But getting to the developing or less fortunate world, we have to make drugs available and supplements that work, that are cheap. And metformin is a perfect example of a drug that's a few cents a day, if that. And as technologies evolve, they will become cheaper. And inventions that we make in our labs will go off patent and eventually become cheap. And that's also the goal. All of my colleagues believe that we're not trying to make money here. We are trying to leave the world a better place, and that will happen.
Yeah, and that's what this is all about, is how can we, and all science is about how can we harness science, including the science of aging, to build a better, safer world for everybody, including the most vulnerable people. So we're out of time.
Can I just say,
Yeah.
This is not all about aging only. People who survive cancer because they get radiation and chemotherapy, they age rapidly. HIV, people get their diseases 10 years
even
earlier.
COVID.
Yes.
COVID people, the people who are disabled have a problem. I would say even poor people that cannot afford to eat or exercise, they could benefit from a drug.
Yes.
And if we want to go to Mars.
And again, it's not about drug. I think that drugs are a piece of the story. It's our ability to understand the mechanisms of aging, to slow aging, to enhance health span, will not only have, as David mentioned, economic dividends, but it will have health dividends across the spectrum. So we are out of time. We could go on forever. Thank you so much to both of you.
Thanks, Jamie. It's been great.